It's a pleasure to be here, you know. From Argentina to Paris is a big trip, and it's always a pleasure. Well, as Sebastian comments, I work in continental Triassic faunas, mostly, not especially in dinosaurs, but in all the other continents of the fauna that the dinosaur origin. So I will try to explain you some basic ideas to understand the origin of this diverse and successive group of animals. Well, when we speak about time, that is the topic of this meeting, you are listening some presentation about present time, future time, but few about past time. But when I speak about past time, I mean millions of years ago, not 100 years ago. What happened at that time? Well, in the spiral of life and time, as you can see here, we can divide the time by the origin of vertebrates in 3 periods: the Paleozoic, the Mesozoic, and Cenozoic eras. These eras start with the beginning of the vertebrates in the Cambrian and finish with extinction events. These extinction events are very important. One of the most important and massive was the Permic-Triassic mass extinction in the 250 years ago, between the Permian period and the Triassic period. This massive extinction affects most of the marine fauna and part of the continental fauna. Another big event of extinction is at the end of the Mesozoic, when the dinosaurs disappear at the 500 years ago, between the Mesozoic and the Cenozoic. These extinctions affect most of the life. And the reason of this extinction are different. One is the volcanics at the end of the Paleozoic, and the meteoric and greenhouse and movement of the continent at the end of the Mesozoic. But when we think in the extinction, we have to understand the difference of the movement of the continent through the time. You can look in the video, a reconstruction from the Paleozoic until today of the plates with the continent movement, and when it starts to be all together in the Paleozoic, in the Rodinia continent, and separate and form again the Pangaea, which you can look here, their movement start to form the Rodinia, and then the Pangaea with the north and south, and separate during the Mesozoic until today with the present distribution. Well, if we understand the time, if we understand the movement of the continent, we can understand the extinction and that our planets have a long, long history. But we concentrate in the Permic at the end of this Paleozoic era with a fauna in the continent that consists of internal ponds that origin in the Paleozoic. They are like huge frogs, sorry, Sebastians, that live in the continent, and they disappear at the end of the Mesozoic with the dinosaurs and the other elements from the fauna during this period are the precursor of the mammals. They are animals of a small size that then one lineage origin in the Triassic, the mammals, and we have a lot of reptiles from a small size, as we can see in the gray one, from 20 centimeters or half a meter with spines. We have semi-aquatic animals of 2 meters. We have aquatic animal and huge terrestrial animal. This stock, basal stock of vertebrates on the continental Permian strata outcrops suffer the extinction, this event of extinction. And some of them can survive, and most of them disappear. And this event of extinction that divide the Permian to the Triassic period affect 95% of the aquatic animal, 75% of the continental fauna. So few lineage come through and survive this extinction. That is a volcanic effect that imagine that the water starts to be so warm, and the salinity alterate all the factors in the seas, and that affect the life of, for example, sharks, ammonoid invertebrates, and less in the continental strata environments. But what happened after this Permo-Triassic extinction? Well, in the Triassic, the first period of the Mesozoic era, most of the lineage that we find today of vertebrates start to be present. Some of them came from the Paleozoic, like the fishes that survive, then the amphibians that, even though the frogs appears in the Triassic, in the first period, and most of the lineage, like the turtles, the crocodiles, the reptiles that we find today, the dinosaurs, where the birds derive, and the first mammal. So the Triassic period, at 250 million years ago, was a very important and key moment in the life of the vertebrates. For that reason, it's so I am here. Well, but how was the environment at the Triassic? We can look here a reconstruction of this Pangaea supercontinent formed by in the north with the Laurasia that includes North America, Europe, part of the Asia, and the Gondwana subcontinent formed by Africa, South America, Antarctica, India. This Pangaea, at the end of the Triassic, start to break up. And for example, the Atlantic start to form the South Atlantic between South America and Africa. This start to break it. But most of the Triassic until form a supercontinent, and the weather was uniform. The Mesozoic was a greenhouse moment. Imagine that the normal temperature was 10 degrees more than now. So it's so hot in one point. And it was support mostly the animal that they can control the temperature, like the reptile. We are mammals, and we control the temperature, like the birds. But the reptile, no. So the weather was propitious for the development of this kind of animals. Well, we can look in the paleoclimatology map that we have some cold weather in the high latitude, and some tropical and warm weather in the low latitude and in the Paleo-Ecuador. They didn't have a different station a lot. We have some monsonic climate at the 30 degrees in the tropicals, with a period of rain and a period of dry weather. But most of this was in high temperature and uniform. And we didn't have a huge geographic barrier that limit the distribution of the animals, as can be, for example, the Atlantic Ocean. No? It was most uniform. For that reason, during the Triassic, many of the continental fauna we can find the groups in Laurasia in the north and in Gondwana. Okay, and how was the plant? I'm talking about tectonic, weather, but what happened in the continental environment? Well, the plants were most composed in the Triassic after the event of extinction by ferns that you know, cicadal, venetital, and we don't have flower plants yet. This appeared at the end of the Mesozoic. So imagine that the vegetation, it was not so tropical like in the Paleozoic, but we have a couple of trees a big tree, but not like, imagine gymnosperms, but not like the big tree that we have today with flowers. You can have here a reconstruction of this environment with these ferns and the kind of animal that we part of this. They are Dinosaurs, Proterocampsids. They are not dinosaurs or precursors from the dinosaurs. So during the Triassic, this is some other reconstructions. In the continental bed and the late of the Triassic, we can look this kind of animal, for example, armored reptiles, all more relate with crocodile, precursors of crocodile, and not dinosaurs. We have the phytosaurs, they look like crocodile, but they are not crocodile, by anatomical difference that doesn't matter today. And we have herpetozooids, they are animals, imagine, it is a 1.5 meters reptile with short hair and carnivorous. These are the common elements in the Triassic, in the late Triassic faunas, in the continental environment, with the dinosaurs appear. So, if we look here, you can look in the left, the time scale, with some division about the Triassic period and some division inside the Triassic. Some numbers indicate the age and the limit of this. And what happened when the dinosaurs appear at the other faunas? Well, the dinosaurs record, the first one, are at the beginning of the Triassic and consist of footprints. Yeah? They are not real bones. But we have information about the pests, because the dinosaurs have only 3 apples, use the fingers, only 3 fingers to support, they are digitigrades. So we recognize the footprint from dinosaurs. And we can see that they appear at the early Triassic. But the first bones, the first fossils that we found untouched, appears at the late Triassic. But we have some animals that they are the precursors of the dinosaur at the middle Triassic. These animals have a size of 50 centimeters. They are too small. Imagine you can look up the skeleton and the elements, the column and the pelvic elements and the limbs. You have here a reconstruction of this, and you can recognize some dinosaur character like the posterior limb bones, the double of the length than the anterior one. They support in the digit, they are digitigrades. For example, the femur is longer than the tibia. A couple of anatomical characters from dinosaurs we can recognize in this small group that they call dinosauromorph, that they are the precursor of dinosaurs that appear in the middle Triassic in Argentina. But the true dinosaurs appear in the late Triassic of Gondwana sediment, mostly. We can look here that many specimens, like Herrerasaurus, well, Pamphagia, Eoraptor, came from Argentina, from the late Triassic sediment, from Brazil with Saturnalia, and more incomplete material came from South Africa and India. But the origin of the group with the basic form came from Gondwana. And at that moment, the fauna, at the beginning of the late Triassic, the fauna composed most with the crocodile precursors when the dinosaurs appear. But with the pass of the time, the dinosaurs diversify very, very fast. And we have represented at the end of the Triassic the main group of dinosaurs, like is the Saurischian, Ornithischian, and Theropod. So it appeared with other elements in the continental fauna, but fast they start to diversify with other groups. And they cross the limit between the Triassic and Jurassic and diversify in the Jurassic and Cretaceous. But only the crocodiles survive the limit of the Triassic with the Jurassic, and the rest of the element of this continental fauna disappear. This is a very characteristic topic and discuss why happened this, because it helped to the survive of the dinosaur line, and most of the crocodile precursors disappeared. Well, but if I speak this about the continental environment, and I speak about the origin of the dinosaur, but if we go to the sea, what's happening in the sea? We have dinosaurs in the sea. What do you think about this? Well, if we look this, we have a flight reptile that they are not dinosaurs, yeah, around the sea. And we have big animals like those with big teeth. That is not a dinosaur, it's a crocodile. Dinosaurs is a very famous carnivorous crocodile that appeared 145 million years ago during the Jurassic. And in the sea, we have this animal similar to a dolphin, but it's a reptile, and is closer related with a snake and lizard than with a crocodile or dinosaur. So during the Jurassic, in the continental beds, we have dinosaurs, but in the sea, we don't have dinosaurs. We have this diverse group of reptiles. And if we go to the Cretaceous period, 100 years to the modern time, so if we have this reconstruction in the 70 million years ago, we can look again these animals, and we don't have dinosaurs, because these huge species are mosasaurs, a characteristic element only in the late Cretaceous of the Gondwana, and they are the most dangerous and carnivorous reptiles, and they are close to the snake and lizards. They are not related with the dinosaur, and the other, these with long necks and small head, the plesiosaurs, maybe you listen about this, they are not related even with the dinosaur. All these fauna relate more with the lizards and the snake today. So, when we speak about dinosaurs, we are speaking about continental animals with several anatomic characters that I will not talk about this because I will boring you. So my idea is you understand that is a group with legs, the posterior leg longer than the anterior, the support with the fingers when they walk, and divide in two main groups that they live during the Mesozoic. The Ornithischian, that compose of a big group of herbivorous animals, quadrupedal, bipedal. Another group that is the Saurischia, separated by character of the pelvic gill, that consists in two main groups, the Saurischia. One of these, they are the quadrupedal and the biggest animal in the world, herbivorous, that is the Sauropodomorph, and the other group are the therops, they are the carnivorous, and from one group, the birds appears and derive. This is try to summarize this diversity of the dinosaurs. Well, what are important the dinosaurs during the Mesozoic? For several reasons, they live a lot of time. Imagine that they live around 200 million years. They live all the period of the group. It's huge. They have a wide diversity of size and forms. For example, in the herbivorous form and quadrupedal, there are diversification of the forms, and they try to fuse the number of fingers to support big animal. We are speaking about animal of 40 meters of length. Yes, the biggest animal in the world in the continental environments. We don't have this now, likely. And this kind of modification on the foot we have today in the heavy mammals, herbivorous mammals, like a rhino, like an elephant. So in other group, at present, we have the same modifications to support big size. Other group are the carnivorous theropod. We can look maybe you think that the Tyrannosaurs, based on Jurassic Park, are the most carnivorous and biggest dinosaurs, theropod, but not really. The Spinosaurs had almost 13 meters of length, when the Tyrannosaur, they calculate around 9 meters of length. So they reach big size, even though in the carnivorous form. And you can look in this part of the slides. This is a graphic that put the relation by ancestrally and descendants of this group. We call this cladogram. And we can look the different reduction of the anterior member. No? It depends in which groups we have that the anterior legs start to disappear. And among these carnivorous and huge animals. So the dinosaurs support a wide diversity of size and forms. But what we know about the behavior of these animals? Because about the anatomy, we know a lot, and the record and the new form. But how are these animals? They are slow and foolish, cold-blooded. They are stupid animals, or no? Because they live more than us. So what we know about this? Well, recently studies start to try to understand and reconstruct and infer the behavior of these animals. One of these lineage of research in all vertebrates is the paleoneuroanatomy. Sorry, it's in Spanish, but maybe it helps. The paleoneuroanatomy study the brain of this animal, and how we can study the brain of an animal that disappeared 65 million years ago. Well, when we found the fossils in dinosaur crocodile whales, we found the skull, or part of the skull that we call brain case. It's a part of the bone that covers the brain. Of course, the animal when died, the brain disappeared, and we found only the bones. We can, and the paleontology, what we do? Well, we fill in again this space in the skull, in the brain case, with latex or silicone, and took a mold and extract and study the mold that show the shape of the brain case. Another new technique is the CT scan. Well, the CT scan that you use when you go to the doctor. Okay, we use for fossils too. Yeah, we put the skull of a dinosaur, a crocodile, whatever, and we reconstruct them by digital 3D dimensions, the space. And we have this kind in yellow reconstruction of the brain and the sensitive organ. For example, the ear. Well, we have here, for example, the Carnotaurus is one of the most dangerous theropod or dinosaur. This species have horns. It's the only that have horns in the head. And look the size of the brain. We have a huge animal of 6 meters in up and a small brain. You can look in yellow the reconstruction. And we can look here how it filled the skull, and we can look and describe, for example, the olfactory bulb, the tracts, the part of the brain. We can reconstruct the internal ear, and it depends the position of semicircular canal like us. They have the same kind of ear. We have information about the sensorial capacity, the balance and orientation of the animal based on the ear in the semicircular canal, and about the locomotion ability. So look what kind of information we have about this animal study, the endocast. Well, but what we know about the growth of this animal? How did they grow? Well, there are new techniques applied in paleontology, but it's a very old technique in biology, that is the histology. We call this paleontology because I applies to the fossils. And we concentrate mostly in the original microstructure of the bones. So we cut a bone. We can see here a femur of a sauropodomorph. It is not easy because sometimes we have only one specimen of this kind of dinosaur, and the curator say, no, you can't cut this, because unfortunately, this is a destructor technique. The material that we section is destroyed. We can replace with plastic or other stuff, but we should convince the curator to do this. But sometimes we have many specimens of this species, so we can do this. That is great, because sometimes we have the small to big size, and we can check if there are different species or there are sexual dimorphism with the technique, because they show us, for example, in this case, that is a long bone, as I mentioned, we can look at the medullary cavity and the cortex, and study the disposition of the tissues in this bone. And we work and study 4 main patterns of this. Well, we can look mainly the cell shape and distribution in the tissue. The same with the vascular spaces, no? We can describe, and the density of them, and the spatial distribution of the collagenous fiber. We can look in the Polaroid microscope. And again, we can look how it's present or no the distribution of growth mark. We can look here, for example, the limit that line, that closed packet of cells, their limit of growing. Like in a tree, we can look the line of growing. Well, we have the same information in the tissues of long bones of animals. So we can infer the age sometime of the animal. For example, in this Gasparinisaura ornithischian dinosaurs, we section the femur again, and we can look in different colors. The purple indicates fibrosis tissues. They are indicate fast growing, and the blue one indicate a slow period of growing. So we can look intercalate these periods of fast and slow growing. We have this kind of information. And we have this, for example, in 2 different species of theropod, fibrocartilaginous tissues that is characteristic for fast-growing animal with a high metabolism. That it means probably they have more they control more the temperature of the animal. And we have other theropod with pseudolaminar tissues in the matrix that indicate a slow growing. So not all the dinosaurs have periods of fasting and slowly growing. No, some dinosaurs have one kind of growth that is fast, another that is slow. And for example, a complementary information, it is in the osteoderms. Some dinosaurs have this kind of osteoderms that we can look in crocodile tooth that cover the animal. And well, it's part of the ossification of the dermis. We section this, and we have this information of the tissues again, about the legs, the age of the animal, and how it's growing. And finally, for example, in this sauropodomorph of big size, we can look the matrix. That is a special kind of matrix. That is the metaplastic origin, that we found the same kind of matrix in the living rhino. The living rhino, that is a huge mammal, herbivorous mammal, is compared and have the same matrix in the bone that the quadrupedal herbivorous and big dinosaurs like this. This kind of information is interesting because, again, we see the same pattern in living forms. Well, and what we know about how they move it, because we know how they feel with the paleoneurology, how they growing with the paleohistology, but we want to know how they move it. They are faster or slowly forms. Well, for that, we have biomechanics studies that concentrate mostly in the bones. No? The bones are from the limbs, at the basal data for understand the growing of these animals. And we can scan externally and make a three-dimensional model, or even though we can CT scan, like the skull for the paleoneuroanatomy, but it's more cost. And with this, we add the muscles and have a model, the musculoskeletal model, in 3D, and apply for this different studies. For example, the moment arm, trying to calculate the line of force that's from one limb to the pelvic or among the limbs of the leg, and showing range of motion. Okay, this is the theory that is clear, but we have these 3D models based in the skeleton, for example, the anterior limb with the scapula and coracoid, the humerus, and the radio ulna and pes. We add the joints digitally, no, the cartilaginous covers of these articulation points that we don't have in the 3D model when we scan the bones. We have to add because we don't have in the fossil record these structures because they are not preserved. And when we add these additional joints and we have all the model, we applied the moment arms reconstructions, how they move it. And then we use some softwares to understand the speed of movement, they are faster or slow, the range of motion, even though the position of the limb, if they are laterally to the body or they are behind the body. And this is very important to understand if they are quadrupedal, bipedal, or faster animal, or they can jump, they can swim. Yeah? We have all of the information based on this, not only morphology, but with biomechanical analysis. And at the end, what we know about the behavior, no? How was the behavior? Did they have parental care or no? Well, we found in Mongolia and other parts some nests with special distribution of the eggs and the dinosaur over him. At first it was casual, but after a time they recognized the paleontology that it was like a chicken over the net. Yeah, it was because they have parental care. And they found some nests with eggs in special places, like this, in the hydrothermal system. So they found and reconstruct by the footprints and from the sauropomorph herbivorous animal that make a hole, put the eggs, cover and live, because they use the hydrothermal system to heat the sources of heat for the eggs. So it implies all parental care. And we have here, for example, an egg from La Rioja, from South Sauropomorph, inside the net, and they study always the shell of the net and found pits, big pits, that with the time start to close for the interchange of the air, and it is related with a hydrothermal system. So, to summarize, yeah, we know today, based on the paleoneuroanatomy information made by artificial endocast from the brain, by letters or digital, how was the brain and the sensory organs, how was the tissues and how they growing fast or late, and the age of the animals. We know how was the nets and put the eggs and indicate, for example, if they put in special places with close the pore or the pit to interchange, because they use the heat source in the floor. So they have the idea to take care the nets. And we know now, for example, with biomechanics study, that small size, they are handled quadrupedal to the adult that change the mode of locomotion to bipedal. So after these studies, we know that the dinosaurs were more complex than we thought previously. Probably They are agile, fast-growing, and warm-blooded. Okay, we have this information that is very, very important. But why did they disappear at the end of the Mesozoic? 6,500 million years ago. What happened? Well, this is for the next time. No more time now. Merci.
Si j'ai bien compris, le cerveau des dinosaures était très petit. Et à la même époque, il y avait des mammaliens qui aussi avaient un cerveau très petit. Il y a 65 millions d'années, les dinosaures ont disparu et les mammaliens ont suivi une courbe d'évolution jusqu'à nous. Pourquoi est-ce que si les dinosaures n'avaient pas disparu, ils auraient-ils pu acquérir une certaine forme d'intelligence et continuer une évolution?
If dinosaurs didn't get extinct, could they evolve towards a kind of intelligent being, or what do you think about this question?
No, I don't think so, because they have another complex structure in the brain, yeah? The mammal will have more developed some part of the brain that the dinosaur didn't have, yeah, to produce ideas, sense. And this part of the brain is not so developed in dinosaurs. What happened, I didn't know. We need a time machine for the future, from the past. And I only say that the mammals appeared at the late of the Triassic and spent a lot of time with the dinosaur, but they were very small, yeah, like a rat, yeah, sometimes, and some, but most of the niche, the ecological niche, are occupied by dinosaurs, yeah. I think that if they didn't extinct by the extinction at the end, probably we are not so here.
What about birds with regard to the development of intelligence? Because some of birds are really pretty smart. Do they have a different or more developed parts of the brain compared to the dinosaurs? Because it's, I don't know, 65 million years later.
The birds, she speaks. Yeah, well, actually the first birds are from the Jurassic, yeah, with Archaeopteryx, and the ornithorhynchidae that they are more basal birds during the Mesozoic. We don't know a lot about the brain, yeah, but they are restricted to some environments. They are not so diverse in the aquatic. They are more restricted to the tree. At that time, imagine that the dinosaurs occupy all the ecological niche. The birds didn't have a lot of possibilities to replace after mass extinction at the end of the Mesozoic. It was the key, because when the dinosaurs are extinct, they left a lot of possibilities to the mammals and to the birds to occupy this niche. At that time, during the Mesozoic, they didn't have this opportunity, because the main predators were the dinosaurs on the continental bed, even though in the aquatic that I show. It's not the dinosaur, but the other group of reptiles.
Brièvement, pour remplir ma tâche de synthétiseur, mais c'est plutôt de poser quelques remarques. D'abord, merci à Julia, parce que pour une fois, on ne nous a pas d'abord parlé de la disparition des dinosaures, mais on nous a parlé des dinosaures eux-mêmes, parce que c'est quand même important. Et puis, vous savez, les anciens se posaient la question, qu'est-ce que sont les fossiles ? Ça ne rentrait pas dans leur vision de l'histoire du monde. Et ils disaient que les fossiles étaient des jeux de la nature. Et là, nous avons une belle présentation qui montre bien que les fossiles ne sont pas un jeu, mais ce sont des magnifiques traces du passé qui nous disent énormément de choses sur les êtres qui nous ont précédés, jusque ce qu'ils avaient dans le cerveau ou ce qu'ils n'avaient pas dans le cerveau. Donc, merci aussi à Julia. Et bref, grâce à elle, nous savons désormais tout ce que nous avons toujours voulu savoir sur les dinosaures sans jamais oser le demander. La question qui reste, c'est tout de même de qui serons-nous les précurseurs ou de qui serons-nous les dinosaures? Merci.
you.